Today we're going to look at graphing logarithmic functions and also finding inverses of exponentials or logarithmic functions and finding domain and range. So the inverse of an exponential function, f of x equals b to the x, so remember x is in the exponent, making it an exponential function, is written as f inverse of x equals log base b of x. Remember back to when we first talked about finding inverses, we always talked about switching x and y and then solving for the y. So yesterday, when we learned what logs were, like this function log base 3 of x equals y, we would have written in the exponential form as 3 to the y equals x. Now that's the exponential form of log base 3 of x. But the actual inverse, we have to switch the x and y, giving us an exponential function with an x in the exponent. Okay, so we always will switch the x and y first, and then that will be our inverse function. Okay, so just like what you thought of it as before, same thing. Okay, an inverse operation will undo the other one. Okay. So remember, if it's an inverse, that means the composition of the functions should give you just 1. In this case, we will be finding that the compositions will give us x, or sorry, that was what it was supposed to give us before. 1x is what I meant. So the composition g of f of x is log base b of b to the x is x. So b to what power? So b to the x gives me b to the x. Well, that's the x power. So it's undoing the other operation. The other one, we have b to the log base b of x is equal to x. So that's going to get you out of the exponent. So these two rules will come in handy when we're solving equations as well. Okay. So let's go ahead and do an example. We're going to simplify the expression. So keeping in mind those last two rules that we had for the composition of the functions. So this first one looks like that b to the log base b of x equals x. So I'm going to write that down for a reminder. So b to the log base b of x. Now remember, this function doesn't have a base written up there, but that will be our common log, so it's actually base 10. So our bases match, b and b. So in this form, we have 10 to the log base 10 of 4, and that's going to equal x. Okay? So everything is the same here, and then we take that 4, and that's what 10 to the log base 10 of 4 is just 4. So that's what that equates to. Okay? It's just whatever was inside the log. Since it was a base 10, the same base. Okay, this other one looks more like the other rule we looked at. So log base b of b to the x is equal to x. Okay, so remember we have to have the same base. So the b and the b right here are the same. But we have a 5 and a 25. Those are not exactly the same thing, okay? So we need to change one of them to look like the other one, so giving us an exponent with one of them. So we want this base of the log, so the 5, we want it to be this, to not change. We want to keep an integer down there if possible. So we're going to leave that as log base 5. And then the 25, to get it to be a 5, well, 25 is 5 squared. Okay? This is equivalent to the 25, to the x. Okay? So now, our rule with that would be 5 to the 2x. So log base 5 of 25 to the x is the same thing as log base 5 of 5 to the 2x, because the 25 is just 5 squared. So now we have something where the bases match. We have a 5 and a 5 that are matching. So that gives us 2x. is our answer. So this simplifies to 2x. Okay, so let's move on. Again, remember that if you need to listen to this again, you just rewind it and go back and try again. And you're always welcome to ask questions when I come back, or to your classmates as well. Okay, so keep that in mind. Okay, find the inverse of the function. Okay, so when we talked about inverses, the first thing we always did was switch our x and y. So the inverse function, if I start with an exponential, which this is an exponential, we have an x in the exponent, then that means the inverse function should have a log in it. If I get to the end and I don't have a log, I did something wrong. The same is true for the other way around. If I start with a log, I should end up with an exponential. So I'm just going to make that note to myself that through whatever I do, I'm going from an exponential to a log. So my answer better have a log in it. Okay. So the first thing, I am going to switch x and y. So I have x equals 6 to the y. Okay. Now I need to get y by itself. So that was always the same thing that we've done before. And the way that I'm going to get y by itself is I'm going to think about this as changing the form. Okay, when I change form from exponential to a log, they are equivalent. Just changing the form that I want to use, the one that is most useful. Now, since I want y by itself, changing the form will give me y by itself. Okay? So if you remember yesterday when we talked about logs, we would take the log base 6, since we want the same base as the exponent. So yesterday we went from log to exponential. Now we're practicing going the other way. So log base 6 of x is equal to y. So let's check that. Okay, so 6 to the y equals x. That's the same thing as up there. Okay, so just like our rule from our definition, 6 to the y equals x. Okay, so this is now y is by itself, and this is a log, and that is our inverse function. Okay, this is just coming from the definition of logs and inverses. So switch x and y, then change our form. So 6 to the power of y gives me x. And that's what the log form is saying as well. Okay. Now let's try another one, but going the other way around. Okay, so I'm starting with, remember this is a natural log, so it's kind of like log base e. Okay, you can put an e there to remind yourself of what that is. So I'm going from a log, and I want to end up at the end with an exponential. So that's a good reminder to write that down so you know if you're done or not. Okay, so first I'm going to switch x and y. So I have x over here, and then I have ln, and I'm going to put the e there just to remind myself. Okay. Now, since I just have a log on one side, I don't have anything added on the outside of the parentheses out here somewhere. Okay. I can go ahead and change form right now. So I remember what my base is. My base is e. So changing the form, that's what's happening at this step. E to what power? So it's not the one that's right next to it. Remember, it's on the other side of the equation. So e to the x equals y plus 3. Now, remember, y has to be by itself. So we have one last step to do, and it's to subtract that 3. So I have y is equal to e to the x minus 3. That minus 3 is not in the exponent. It's just down below. And this is the exponential form. There is an x in the exponent. So it's an exponential equation, and that is the inverse function. Okay, by switching the x and y, I get the inverse. So no longer a logarithmic function, it is now the inverse function, which is an exponential. Okay, this is kind of tricky, so I'm going to do one more example. It's not on your handout, and so I want you to go ahead and write this one down, either on, if you have more space on the handout, or on a piece of paper, so that we get one more example of that. Okay, so we're going to start with this one. We have y equals 3 to the x plus 2. I'm finding the inverse. So this is an exponential function, which means I want to end up with a log. There has to be a log in my answer. Okay, so remember, the first thing I want to do is switch x and y. So x is equal to 3 to the y plus 2. Now, when I change form, the only way to change form is if your exponential function is by itself. Okay, so at this point, I can't change form because I have this plus 2 out here. So I need to get that on the other side first. So I have 3 to the y. So anytime I have the y part, that has to be either inside the log and there's nothing else there, or in this case it's with the exponential and there's a plus 2 on the outside of your exponential. So you have to get rid of that first. Okay, so I'm going to subtract 2 from both sides. So I have x minus 2 equals 3 to the y. So now 3 to the y is by itself, and I'm going to change form. Okay, so changing form, this is going to be equivalent to this. This is not an exponential anymore because the exponent is a y, not an x. Okay, so the changing form, I'm going to have log, and then the base is the same as the base of the exponent. So it's 3, log base 3 of x minus 2 equals y. So 3 to the y equals x minus 2. Okay. So just kind of a reminder, when you change form, it's not just adding a log in front of this 3 to the y. Okay. That's where you get you go to the outside and then go back to the inside. So it's kind of like, it's not just adding a log to one side of the equation. Okay, that's where you can kind of get caught up sometimes. Okay, we want to get that y by itself. So the y is by itself. We have the same form, or sorry, not the same form, but it is now a logarithmic function, which is the inverse of the exponential. Okay, so the goal, just kind of reviewing with inverse functions, the first thing you'll do is switch your x and y. Then you need to either have the log part by itself or the exponential part by itself, depending on what it is. Then you need to change the form. So if it's an exponential, change it to a log. If it's a log, change it to an exponential. And then check yourself, make sure it goes with the definition of what a log function is. Okay. We're going to go ahead and move on to graphing. So graphs of logs, remember it's the inverse function. So what's happened is that it has switched our x and y from the exponential, so it's reflected over the line y equals x. So instead of having horizontal asymptotes like we did with exponentials, now we have vertical asymptotes because they have reflected. So here's an example of one of the parent functions for the log. It's going to look more like this, and it's going to get closer to this vertical asymptote of x equals 0, and then increase x at the logarithmic. It's going to keep going, and it's going to look like it's leveling out, but it's It's that inverse function, and it's kind of, if you turn the other graph over this line, y equals x, this would have been the exponential that gave us that, something like this. Okay, so reflecting it. So now we notice that our values for our log function are not going to be negative. Okay, we'll look at that when we're graphing why that is true. So x equals h, this part is the translation. So x equals 0 will be the asymptote on the parent function. Okay, and then that is translating it left and right. So if we have a translation, now we're looking at this h value and not the k. The k is moving it up and down, but if you move a vertical asymptote up and down, it's not going to move. Okay. So I'm just going to kind of sketch out the other one. This would be the exponential and the log if our b is greater than 1. Okay, if our b is between 0 and 1, so remember b is still our base, so the base of the exponential becomes the base of the log, we would have something like this where we have the decay. Okay, but that's reflected over this line, and we get something that looks like that for our log. Okay, so to tell the difference between an exponential and a log, we'll be looking at the asymptote. That's the easiest way to tell the difference right away, because this kind of looks also like a exponential that has been moved down. So you have to pay attention to where that asymptote is, and that's why I'm so stringent on labeling your asymptote. Okay. So let's go ahead and talk about how to graph these. Okay, graphing a log is just a little bit different than anything you've ever done before. Okay, since you're not an expert on logs yet, we just have one day. It's easier for you to think about it in the form of an exponential function. Okay, but when we graph a log, we don't ever switch x and y. Because if you switch x and y, then it's finding the inverse function, and you are now finding the exponential. So it will look like an exponential graph. Okay. So when we graph a log, what you're going to do is change the form, but don't switch x and y. So I'm changing the form to an exponential. Okay. This makes it easier if we plug in x's here. You have to think about which x's that you can plug in that you can find y's for. So it's easier to think about it in the exponential form. Okay. So the base of this log is 1/2, and so it's 1/2 to the y equals x. This is the exponential form, but it is not an exponential function because the y is in the exponent and not the x. So that's why you can't switch your x and y. Okay, it's very important. So we changed the form. This is the same function, it's just in a different form. It's in the exponential form. Okay, so now we're going to pick our points. Okay. This is where it's a little bit different than what you've done before. Okay, all through your math career, you've always picked x's and then plugged them in to find y's. Okay, in this situation, it's going to be easier for you to pick y values and plug the y values into this exponent to find what your x value is going to be. So this ends up being just like graphing exponential functions or plugging in numbers to exponential functions, just you're plugging in the y values, okay, because it's not an exponential function. So again, whenever we plug in our points, it's going to be just like graphing the exponential. We are going to pick 5 points, and those are going to be y values, -2, -1, 0, 1, and 2. So not picking x values for logs. Okay? X values are harder to pick when it's in this form. So now it's just like before. I'm plugging the -2 in for y and finding what x is. So 1/2 to the -2, that's going to flip the fraction, and I get 2 squared, which is 4. So 4 is my x value. I plug in -1, it just flips the fraction, and I get a 2. Plug in 0, 1/2 to the 0 is 1. Plug in 1 for y. 1/2 to the 1 is just 1/2. And plug in 2 for y. 1/2 squared, that distributes to both, so I get 1/4. So it's 2 squared, and that's 4. Okay, so nothing really is different except for that you are plugging in your y's. So the process is just the same as you did for exponentials. We just have one additional step. From the log, you have to change the form from a log to an exponential, and then you're plugging in y's. So that's why it's just a little bit different. Okay. So now let's plot those points. We're going to go over 4 and down 2. And then you're going to go over 2 and down 1. Over 1. Over 1/2. And 1/4. Okay, so remember it's the inverse function of an exponential, so that's why we're putting in our y values. It's like we've switched them from the exponential. And so you should see some of these same points. It would have just been, if you switched the x and y, it would have been reflected over the line y equals x. Okay? So now we have our graph, and we have the line x equals 0 is our asymptote. And then this is our logarithmic function. So we have a vertical asymptote, and we've plotted all those points. Okay, so now we're going to look at domain and range. So since we've switched our x and y from the exponential, it's an inverse operation that switches the asymptote from horizontal to vertical, and it switches our domain and range. So now we're going to have a restriction on our domain. So you notice none of our x values went negative. So they start at 0. That's because I can't plug in any y values that are going to give me x values that are negative. Okay, because it's in the exponent. So just like before with our range, now our domain is going to start at 0 and go to infinity, the positive infinity, but it's not ever going to touch 0. That's an asymptote. But our range, we can plug in whatever y values we want, so that is negative infinity to infinity. Okay, so this is a little bit new. We're going to do another one to make sure you've got it. Remember, you can always come in and ask questions if you have them. All right, example 8. So we're going to graph this again without a calculator, state the domain and range. Now you'll notice with this one we have a translation. So just like what we did before, we're going to graph the parent function and then translate it so that it's easier for you to pick your points and figure out where they should go. So the parent function of this would be y equals log base 2 of x. And then the rest of that tells me which direction everything is going to go. So this part tells me to go left 3, and this part tells me to go up 1. So at the end, we will use that. So first step again in graphing our log, we are going to change the form to exponential. So that means it's going to be 2 to the y equals x. So remember, the x is not in the exponent. So it's not an exponential function. It's just in the form of an exponential because the y is in the exponent. Okay. Now we're going to pick our x and y. numbers. So we're going to pick values for y, again, -2, -1, 0, 1, and 2, and plug in the y values to find our x values. So plug in 2 to the -2, and that's 1 over 2 squared, which is 1/4. Plug in -1, that just flips the fraction, so we get 1/2. Plug in 0, 2 to the 0 is 1. Plug in 1, 2 to the first is 2. Plug in 2, 2 to the second is 4. So those are all of our points in our parent function. So we're going to graph those and then translate them. So we have 1/4 -2. 1/2 -1. 1, 0. 2, 1. And 4, 2. So this is our parent function. And we have our asymptote at x equals 0. Now, instead of looking at the +1 to tell where the asymptote is going to go, we're looking at which direction, left or right, we're going to go. So that +3 tells me I'm going to the left 3. So my new asymptote is going to be at x equals -3. So always draw on that asymptote first. Then I'm going to move all my points over, left 3 and up 1. Left 3, left 1, left 3, left 1, left 3. So that is the translated function. Now the domain and range for the translated function, we're looking at domain, that's our x values. The first x value I come to is -3, and I go to infinity in that direction. So I start at -3, go to positive infinity. Range, again, is all reals because I can plug in any y values that I want. It's going to keep going down forever and keep going up forever. That is our domain and range. All right. So again, remember, if you have questions, don't hesitate to ask and come in for help.